Okay, so um, I'm making a video today in kind of a new format, MS Paint. So let me know what you think of it. Just makes it more interactive for me and easier for me to kind of make problems as I'm talking. But today I kind of want to talk about something more fun and interesting almost, and that's infinite radicals. So let's say you have some number x plus the square root of x plus the square root of x onto infinity. So it just keeps going on and on and on. And you might think, okay, well, how are you supposed to calculate that? Because that's an infinite number. Let's say that number equals w. Well, what does that number equal? You don't really know. But the thing is, there's one trick that you can kind of use to find the number exactly. So since this is an infinitely long root and it's infinite roots inside of one another, we can express this whole part of the problem. So everything except the first x in the radical, we can express it as w. Do you understand why? So basically, it's still an infinitely radicalized root that has the same expression as w. It's still w because it goes on infinitely long. So this might seem mind-boggling at first. We can write this now as x plus w is equal to w. Then what do we do to solve for w? Well, first, order of operations, we square both sides. So we remove the square root because we're squaring this and we're squaring this. So we get w squared. Then now we can take it all to one side so we get a quadratic equation. So we're going to have 0 equals w squared minus w minus x. Okay, so we have our quadratic formula now, right? So let's say we want to find uh, what this number w is. Well, we also have a coefficient x. So right now, this might be kind of ugly to do for just a general case. So let's put a number in. Let's put some number, let's say 6 in there. I'll keep this general formula still up here. Let's do the square root of 6 plus the square root of 6 plus the square root of 6. You see what I'm trying to say? Onto infinity. And we want to find what that equals. Well, so let's make that w so we can do things to question mark. So now we know this part is w. So it becomes square root of 6 plus w equals w. Then 6 plus w equals w squared. W squared minus w minus 6 is equal to 0. Well, realizing it now, the nice part about 6 for this is that 6 has two factors. Try to pause the video and find them. You should be able to. So the two factors are 3 and 2, other than 6 and 1, of course. But 3 and 2 are the two factors that we can form some combination where it equals -1. So that's, of course, 2 minus 3. But since we have -6, we have to have a positive negative. So it's going to be w minus 3 times w plus 2 is our factorization. And then that means, and this is equal to 0, by the way, I should put that in. That means that w can either be 3 or -2. But one of these solutions is erroneous. So it's -2 because we're adding positive numbers and we can't get a negative number. So the answer is 3. So this infinitely nested root of 6's is equal to 3. It's kind of fascinating. And if you want a brief calculus explanation on it, it's pretty much just because, so the fact that we can represent this as the answer is because this approaches, so the limit as the amount of radicals, let's say, is n, as that approaches infinity, the value of w approaches w. And so w minus 1 is also going to approach w. So kind of an intuitive thing, but it's really cool because this is the only place you kind of see it in math. So I kind of want to show another example. So let's look at something a little different than this. Just trying to make some space. So let's say we have the square root of 6 times the square root of 6 times the square root of 6 times the square root of 6, on and on and on and on. And this equals w. Well, we can use the same logic. This is going into infinity. We can use the same logic. This is now w. So it becomes the square root of 6w equals w. And then that means 6w equals w squared. And then that means that w is equal to 6. And so it works out nicely. So yeah, it's kind of a nice thing. So let's say for example, we have something where um, for multiplicative infinite roots like this, it'll always be nice because this first number in here, this number that repeats, is always going to be the answer. But for an infinite root, let's say we have the number 28 plus square root 28 onto infinity. Okay, the answer when you solve it, so you're going to get something like this. So you're going to get, instead of 6 plus w equals w squared, you're going to get 28 plus w equals w squared. So since this doesn't have a nice factorization where the two factors can add to equal 1, you use you'd use the quadratic formula. So you would do when you put this into like a quadratic form, it's going to be 0 equals w squared minus w minus 28. And then x is equal going to be 1, since it's the opposite of b, which is negative 1. So I'll write it down here. B equals negative 1, a equals 1, and then c equals negative 28. So it would be 1 over 2, so 2 times a, 2 times 1, plus or minus square root of 1 of 4ac minus b squared. So 4, so it's going to be 1, or I said that backwards, b squared minus 4ac, my fault. So minus 4ac. So 4 times a times c is negative 112, and that's a plus here now. And then all that over 2a, so it's 2 again. So this is a really ugly number, but it's going to be x equals the square 1 plus or minus the square root of 113 over 2. But this minus here doesn't exist as a solution because, again, similar to the case over here, it's a negative number, and positive numbers can't equal a negative number. So your answer would be x equals 1 plus square root over 13. Okay, I hope this video kind of showed you a little trick for solving this and maybe enlightened you a little bit. Thanks for watching.